asked a question about the triangle inequality theorem. So when I get a math question, I try to walk through it. So let's kind of go through it. So the triangle inequality theorem says that if you have this three-sided figure, a triangle, any two sides have to sum to more than the third side. So for instance, in this picture, A and B, right, the orange and the green have to be more than the blue side C, or A and C have to sum to more than B, or B and C have to sum more than A. So let's think about the logic of why this is true. So when I used to do this in class, I actually sometimes would call a person up. So we'll pretend I'm like 5 feet tall. Okay, so I'm 5 feet tall. And let's say that I called up a taller student. Let's say I called up a 6 foot tall student. That's a very tall student. I don't know why I didn't have arms, but there we are. Okay, so you're a 6 foot tall student, and we would stand a certain distance apart. I don't know. Let's say that we stand 3 feet apart. And then we would kind of like fall in towards each other, and we'd catch each other, and sure enough, what would end up happening is we would sort of inadvertently make this triangle, which is a 5, and a 6, and a 3, right? And none of this is drawn to scale, but you get the idea. Okay, 5 and 6 and 3. Okay, now you'll notice that if I take the two smallest sides, 3 plus 5 is more than 6, that's fine. 5 and 6 is obviously more than 3, and 3 and 6 is more than 5. So this is a triangle by the triangle inequality theorem. And so basically what's going to happen is I can keep moving myself and the 6 foot tall giant student farther and farther apart for a while, right? So like we could be 4 feet apart, and that would be fine. We could be 5 feet apart, and that would be fine. But at some point, right, if we get too far apart, right, then we would both fall on our faces. In fact, specifically, if we stood 11 feet apart, and here's 5 foot tall me, and here's 6 foot tall student that is taller than me, and I fall in, oh, flat on my face, and the student falls in, again, not drawn to scale, flat on my face. So the 5 and the 6, we wouldn't make a triangle, we'd make a flat line. It would also be incredibly painful. So the short version is that in whichever permutation of, that you have of this, that any two sides have to add to more than the third. What this fundamentally means in terms of looking at problems is that really you're looking to see if the two smaller sides add up to more than the biggest side. So in this case, the 3 and 5 were the only ones that could possibly not be big enough to add up to the 6, right? Since the 3 is the smallest side, we have to consider the two smallest sides, do they add up to more than the third, right? And so it is true that it has to be every pair of two sides has to add up more than the other third side. But really, if you look at the two smallest, you can kind of figure that out. So what this means is, let's say we're given two sides of a triangle. Let's say we're given that A in a triangle is, I don't know, 5, right? And B in a triangle is 4. So the question is, what are the values that C could be? Well, we know that C has to be more than, has to be less than the sum of the other two sides, right? We know C has to be less than the sum of A and B, so C has to be less than 9, right? So we know that about C. But we also know that on the small end, since B is is the smaller side, maybe C isn't the biggest side. So like if C is the biggest, right? If C is the biggest, it would have to be smaller than 9, right? But what if C was the smallest? What if C was a small side just like B, right? What if these are the small sides and A is the biggest? What if that's the biggest side? Well, if A were the biggest side, then A has to be smaller than the sum of B and C. So 5 has to be smaller than the sum of 4 plus C, right? So 1 has to be smaller than C, or C is bigger than 1. So basically, I could pick any C between 1 and 9. So one way that you might see this question is it might say something akin to, if you know the two sides of a triangle are 5 and 4, what's the range of possible perimeters for the triangle, or what are the range of possible values for C? So basically, I could have any C value in this triangle, given the information I know, between 1 and 9, which means that I could have any perimeter value, right? Since this is already 9, I could have any perimeter value that is between the 1 plus the 9 I have, which would be 10, and the 9 plus the 9 I have, which would be 18, right? So the perimeter would be between 10 and 18 exclusive, meaning not including 10 and not including 18, not including 1, not including 9. So in some problems, they'll specifically say what's the largest possible value of C. So let's say I'm given two sides. I'm given A is, I don't know, let's do 3, and B is, I don't know, let's pick 7, right? And I don't know what C is, right? So I could be asked, what are all the possible values of C, right? So we could say, what are all possible integer values of C, right? So, well, there's two ways to consider this. One is, what if C is the biggest, right? So option 1 is, what if C is the biggest side? right? Well, if C is the biggest side, then C has to be smaller than A plus B, which means C has to be smaller than 3 plus 7. C is smaller than 10. So the biggest that C could be is less than 10. So if it's integer values, the biggest C could be is 9. If you're allowed to use decimal values, then you could have like 9.99999 or repeating, right? But the other option is, what if my C was the smallest value? And the reason I'm not considering what if C was in the middle is because C being in the middle is going to be covered by the fact that I'm writing two inequalities, one lower bound for C and one upper bound for C. So if C was the smallest, then my other small value, which is 3, right, then B would have to be smaller than my other small value, which is A, plus C being the smallest, right? So 7 has to be smaller than 3 plus C. 4 has to be smaller than C, so C is bigger than 4. So this would be my lower bound for C. So basically, C could be any values. Oh, meant to switch colors, my bad. C could be any values between 4 and 7, right? And then if I were asked the extended question about the perimeter, I would recognize that these two together are already 10, so my perimeter would be between 14, because the 10 plus the 4, and between 17, right? Now, again, we don't have to worry about what if B is the middle of the values because we're just finding a lower and C rather. We're just starting to find a lower and upper bound for that missing number C. Now, if they say that C is the biggest side, or if they say what is the largest that C could possibly be, well, then you only have to worry about the top bound. So in the problem that I saw, they were only asking what's the upper bound of the perimeter. So you'd only really have to worry about this red stuff, not about the green stuff as well. Hopefully that's a little bit helpful. If not, just let me know, and I am more than happy to help in any way I can.